Today in this lecture we are going to discuss the energy signal and power signal. We will cover the basics, that how can we say that the signal is an energy signal or the signal is a power signal. So the topic is energy signal and power signal. The basic definition is that a signal is said to be a power or energy signal if the total power energy transmitted is finite. Like the energy of the signal is always held between 0 to infinity, and the power of the signal is always between 0 to infinity. Simply we can define that if a signal is said to be a power signal, then it can't be an energy signal. So it means that if a signal is a power signal, then it can't be an energy signal. Similarly, if a signal is said to be an energy signal, then it can't be a power signal. So that is a straightforward concept about the energy signal and the power signal. So mathematically we can write energy signal in the following way. Like we can define that energy signal is equals to minus t to t x of t square dt. So if you write the energy signal in this format, so it means that the energy of the signal is finite duration. But if you take the limits, like you said that okay, so the limit t tending to infinity, and then you write minus t to t and then x of t whole square dt. So it means that the duration is infinite. Similarly, mathematically, you can write the power signal, and the power signal is something like that, that P of x is equals to, so 1 over t and then minus t by 2 to t by 2 and then xt whole square and dt. So if this is the format, so it means that it is finite duration. But if you put the limit, like power of the signal and the limit t approaching infinity and then 1 over t by 2 minus t by 2 xt whole square and dt, so in that case it is infinite duration. No doubt in many books this the formula is written like 1 over 2t, and then in that case it is minus t to t. So that is also correct, but we are following that formula that power is equals to 1 over t, and then the limits is minus t by 2 to t by 2. So the major concept that you need to follow, or you need to always keep in mind, that power of an energy signal is 0. Like it is a very straightforward answer. Like if someone is going to ask you that what is the power of energy signal, so you don't need to calculate the power of the energy signal. You can straightforward say that okay, the power of the energy signal is 0. Similarly, if someone asks you questions what is the energy of the power signal, so it means that you again answer that question straight away, like energy of power signal is 0. So this is the most fundamental concept that you always keep in mind, and it will help you in calculating the energy and power. So for example, if a signal is said to be an energy signal, so then the total energy carried must be finite. And in the same way, if the signal is said to be a power signal, then the total power carried must be finite. So suppose we are going to solve an example of a given signal. So if this is a signal, so the time index is the x-axis and y-axis is the x of t, whose amplitude or the voltage level is A. So you can represent that signal A, that x of t will always be equal to A, and the duration is 0 to t, like 0 and then small t and then capital T. So when this is the duration, then xt will always be equals to A, and otherwise it will be equals to 0. So it means that this is the portion that when your xt will always be equals to A, and then beyond capital T to t or plus infinity, it will be 0, and similarly from 0 to minus infinity, the xt is 0. So if you want to calculate the energy of that signal, so you can use the finite energy formula, and then the limits is minus t to t. So it means that if you want to insert limit to minus t, so you see that there is no signal on the negative direction. You only have the signal in the positive direction, that from 0 to t. So you can better replace the limit from 0 to t, and then xt is equals to A, so A square and then dt. So A is a constant, you can take out constant and then you can take the integration. So integration of integration will be equals to A square and then t, and then insert upper limit and lower limit. So that is equals to A square and then upper limit minus lower limit. So that is equals to A square t joules. So this is the energy of that signal in the duration from 0 to t. So similarly, you can say that if energy is finite, the signal will be energy signal, and it can't be a power signal. Like you can say that the power of the energy signal is always equals to 0. So you can straight away say that the power is 0. Similarly, if another example is given, like if this is the example, so that is xt is equals to rect and t upon t naught. So that is t naught, so minus t naught by 2 and then minus t naught by 2 and then t naught by 2. So this is t, so that is 0. So from minus t naught by 2 to t naught by 2, so the amplitude is equals to 1. So if someone asks you to calculate the energy of this signal, so then it is also straightforward, like you can use that formula E of xt is equals to, so from minus t naught by 2 to t naught by 2 and rect t by t naught dt whole square. So it means that the rect t by t naught is always equals to 1 between this duration from minus t naught by 2 to t naught by 2. So you can replace that formula with this sign, minus t naught by 2 to t naught by 2 and then 1 square and dt. So the answer is t, and the limit is minus t naught by 2 to t naught by 2. And then you can further, like if you want to insert the limit, so Ex is equals to upper limit is t naught by 2 minus lower limit t naught by 2. So it is equals to t naught by 2 plus t naught by 2. So that is equals to t naught joules. So that is the energy of that signal. So it is straight away that you can say that, okay, the again the concept is that you can easily calculate the energy of a signal, of a given signal, using that formula. And if someone asks you to what is the power of that signal, so you can say that the power of that signal is 0. and you need to make in your mind that these two major concepts always it is the question is always asking that what is the power of an energy signal, so that is always zero, and what is the energy of a power signal, so that is always a zero. So that's it today, that I hope that you understand the energy signal and the power signal very well. But if still if you have any question, like if you want more, if you want to understand some more concept about the energy signal and power signal, so you are most welcome. Like you can write in the comment box what is your suggestions. Thank you for watching our lecture.